Assalamualaikum and good morning everyone. Dengar tak?
Waalaikumsalam dengar sir.
Okay, bagus. Alright, so sorry about cancellation of class yesterday. So for today's class, it's going to be first lecture for this week. And your second lecture later will be the section 3 one, okay? The section 3 second lecture. So the lecture will be recorded and I want you to watch the video in YouTube. Okay, so for today, we are going to look at your quiz 12. So I hope you already have some idea about how to calculate important things in root locus and sketch the root locus, even though you maybe not really understand what you have done. Okay, so today hopefully I can explain to you, and if you have any question, just ask me, because sketching root locus is quite complicated and requires experience and understanding. Okay, so if you have any problem in understanding my sketch, okay, my calculation, just let me know. Okay, so before we go into sketching the root locus, we need to look at the rules first. Okay, so in general there are 8 rules. So the first rule is you have to, of course, determine the poles and zeros of your transfer function. Okay, that's the first rule, but it's not included in here. But you need to find poles and zeros of your transfer function, either closed loop transfer function or the forward transfer function, depending on what kind of system, either unity feedback or non-unity feedback. Okay, but in your quiz, I think it's all unity feedback, so you only need to find the poles and zeros from the forward transfer function GS. Okay, so after you found the poles and zeros, so you need to first determine the number of branches. Okay, number of branches of the root locus depends on the number of poles or zeros, whichever has the many, okay, the most. Okay, we will see later what is the meaning by number of branches. And the second one is the root locus must be symmetric about the real axis. Okay, so you must draw it to be symmetry about the real axis, and this is one of the most important rules. If you draw non-symmetric, then it's wrong. Okay, so rule number 3, I've told you in last week lecture. This rule is quite complicated, but the meaning basically is that the root locus exists to the left, okay, to the left of an odd number of real axis. So we take this as to the left, okay. Sebab panjang sangat dia punya rules. And number 4, the root locus must start or begin from poles, ends at zeros, okay. So mesti mula dekat poles dan berakhir dekat zeros. So must have the direction arrow, okay, mesti ada arrow. And number 5, the root locus approaches straight line asymptote, okay, so ada asymptote. So asymptote has its formula. So I think in your quiz 12, I already list down the formula, so that's basically your notes, okay. So there are 3 more rules which requires calculation. So the first one is breakaway and break-in points. So the formula is already inside the quiz 12. And the second one, JW axis crossing. So this one you need to use Route-Hurwitz criteria, okay? So you must go back and revise your Route-Hurwitz criteria. And lastly, angle of departure and arrival. Okay, so we look at the question from quiz 12. So the first question is, maybe I should open the PDF. Okay, so quiz 12. Okay, so these are the rules, the steps. Okay, so quiz 12, number 1. Given unity feedback system forward transfer function, GS. Okay, so first question asks you to find the asymptote. Okay, so let's do this. Okay, do this question. Okay, so given GS, so given GS equals K times S plus 1 divided by S plus 2 and S plus 4. Okay, so this is unity feedback. So unity feedback means that your simplify. You don't have to simplify in order to determine the zero and poles. So you can straight away determine poles and zeros from GS. Okay, so from here, the poles will be S equals 0, minus 2, minus 3, and minus 4. And then the zeros will be S equals minus 1. And since you have 4 poles, you need to add 3 more zeros so that they are equal in number. Okay, so here you need to add 3 more zeros. So you need to add infinity, infinity, infinity. So 3 more zeros at infinity. Okay, so if you look at the rules, so the first rule said determine finite poles and zeros. Okay, so you have determined. So I have determined the poles and zeros. And then the number of branches equals to the number of poles or zeros. Okay, so here you have 4 poles and 1 zero. Finite, okay, finite 0. So 4 poles meaning that you have, the root locus has 4 branches. Okay, branches maksudnya ada 4 graph lah. Okay, ada 4 graph. There are 4 graphs in the sketch. Okay, so here your root locus has 4 branches. Okay, so basically this is rule number 1. Okay, so rule number 1, you determine poles and then determine you determine poles and zeros and then determine the number of branches. Okay, after that I ask you to sketch them on S-plane. Okay, so you can skip this later because it's easy if you sketch everything all together. So now we look at rules number 2. So rules number 2 says it should be symmetric about real axis. Okay, so this one we can skip first because symmetry we need to sketch. Okay, sketch the root locus to be symmetry. And then the root locus number 3, the root locus begins from poles and zero. So we can also skip this first because this is on later we will sketch them using these 2 rules. Okay, so question A, basically rules number 4. So rules number 4 asks to calculate asymptote using this formula. So question A asks you to find the asymptotes. Okay, so we can calculate the asymptote. So basically rules question A, or I would say rules number 2. So asymptote. Okay, so first we need to determine the real axis value of the asymptote. Okay, so real axis value equals the sum of poles minus the sum of 0 divided by number of poles minus number of 0. So here, sum of poles will be 0, minus 2, minus 3, minus 4, minus sum of 0 is minus 1. And then divided by number of poles, 4 poles, minus 1, 0. Okay, so here you will get minus 9 plus 1. So you get negative 8 over 3. Okay. And then you determine the angle of asymptote. So the angle of asymptote, basically the formula is 2k plus 1 times pi divided by number of poles minus number of 0. So equals 3, okay? Same as this one. And then you determine for each k, starting from k equals 0 until you get theta bigger than 2 pi. Okay, so we start with k equals 0. So theta A equals pi over 3. So this is the first angle. Second angle, when k equals 1, so you get theta A equals pi. And then k equals 2, you get theta A equals 5 pi over 3. Okay, but when you substitute k equals 3, so k equals 3, theta A will be 7 pi over 3. So this is more than 2 pi. So we don't want this value, okay? Because it's bigger than 2 pi, so you stop calculate for angle of asymptote. So here, there are 3 asymptotes starting at this point, and then have 3 asymptote at this angle, pi over 3, pi, and 5 pi over 3. Okay? So this is the answer for question A. Okay? And then question B asks you to calculate the JW axis crossing and then determine the value of K for system to be marginally stable. Okay, so this is the same as rule number 5. Okay. Okay, so you need to use Rutherford criteria. Plot diagram, okay, the transfer function. So the transfer function given here is GS and unity feedback. So you need to calculate the closed loop transfer function. Okay, so I name it closed loop transfer function. T closed loop equals GS divided by 1 plus GS. Okay, because HS equals 1. So here you can straight away simplify, becomes S plus 2, S plus 3, S plus 4, plus K times S plus 1. Ks plus 1. Okay. So to use Rutherford criteria, you need to take the denominator. Okay, so denominator is S plus 2, S plus 3, S plus 4, plus K, S plus 1. So you need to simplify you need to expand the denominator so that you can use Rauch-Hurwitz. So it becomes S square plus 2S so you get S power 4 plus apa lupa dah kira dia. Okay, S plus 4 plus 9S cube plus 26S squared plus K plus 24 S plus K. Okay, so you have this, then you can draw the Rauch-Hurwitz table. So you can start with S4 and followed by S cube so here 1, 9, 26, K plus 24, K 0. And then you calculate for S2. So for S2, you get, okay, you can show in terms of determinant or you can straight away simplify the calculation. So here, you will get 110 minus K divided by 9. And then here, 9K over 9, 0. And then S1, you get 210 minus K, K plus 24 minus 81K over 210 minus K, 0, 0. So here 9K, 0, 0. At row S1. Okay. So look at row S1 and take this value, the first column, and make it equal 0. Okay. So use row S1. So you get 210 minus K.
Betul.
Ya.
Ni yang S1 tu kan. Bukannya 210 tolak K bahagi dengan 9?
Ya. Kat sini yang bagi dengan 9 tu kita boleh simplify kan. Sebab dia sama. Boleh factorize.
Okay.
11
K tu dah.
slide 9K tak nak 9.
Okay dah.
Thank you sir.
Tapi dalam slide tu dia tulis K kan.
Ya.
Salah lah.
Okay,
Oh, slide ni salah.
Dia tricky. Nak bagi korang salin je. Betul lah langkah.
Sebab
9 dah memang bagi 9. Betul-betul ni boleh kan nak simpan.
Korang kat UMP ke?
Okay.
9K dah 9.
Cuma disimplifikan bawah ni, dia tak nak ni ada fraction.
Okay dah. Buat buka kan. Okay dah. Terima kasih dah.
Okay. So here row S1 you expand. So you get minus k squared plus 105k plus 5040 equals 0. And then you will have two values of k. So you get k equals 140.8 and negative 35.8. So you only take the positive value. So then you can conclude for marginally stable system, k equals 140.8. Okay. Okay, and then the question continues. Then find the JW axis crossing. Okay, so JW axis crossing meaning that you are required to determine the frequency for marginally stable system. So after you found k equals 140.8, you use this k and substitute into s square. Okay, substitute into s square, the root s square. So you will get so use s square. So you get 210 minus 140.8 s square plus 9 times 140.8 equals 0. Simplify, then you will get s equals plus minus 4.28 j. Okay, so this is the JW axis crossing. Okay, so you can maybe put a remark here. JW crossing. Okay. So for JW crossing, you use row S1 to determine K, and then use the value of K on row S2 to determine the JW axis crossing. Okay, and then lastly, the question asks you to sketch the root locus. Okay, so after you get all of the information, you can try to plot poles and zeros first in the S-plane. So, alah. Okay, lukisan saya buruk. Okay, so kita buat sikit. Okay, and then okay, so kita plot poles and zero dulu. So the first pole is here, 0. So sketch tu roughly lagi, tak payah guna kertas graph. And then at -1 is the 0. Okay, so if you plot poles and zeros on S-plane, you get 1 mark. Okay, so don't forget to plot them even if you don't know how to sketch. Okay, so plot poles dah dapat marker. And then the second thing you need to do is to put the asymptote. Okay, asymptote is at minus 8/3. Angle pi over 3, pi, and 5 pi over 3. So negative 8/3 is somewhere around 2.8, 2.6. So it's somewhere here. So ni sigma A. And then you can roughly sketch the asymptote. Buruknya lukisan. Okay, so asymptote. So this angle is pi over 3. And this angle is 5 pi over 3. Okay. After that, you put the JW axis crossing, which is at 4.28 J plus minus. So it should be somewhere around, let's say here, 4.28. Okay, so after that, you have to use the first two the rules here, the rules number 2 and rules number 3. So rules number 2 says it must be symmetric about real axis, and rules number 3 says start from poles and ends at 0. Okay, so we need to start with the first pole on the left hand side. Okay, so we start from here. So if you look at this pole, so the rule says that the root locus must start from poles and ends at 0. So if you look at this pole and you know that this is 0 and 3 more zeros is at infinity. Infinity means at somewhere very far, okay? So if you draw this root locus from here, you cannot draw it such as like maybe something like for example like this, okay? Because you want to make the root locus go to infinity. Because if you draw like this, then it is not symmetry, okay? Macam mana nak simetrikan garisan ni dengan garisan kat bawah? Tak ada lagi garisan kat bawah. Okay, so you cannot draw something like this. Even if you draw like this, it will cross the asymptote. Okay, so you tak boleh draw dia keluar ke asymptote. So nak simetrikan dia, so you want to make this symmetry, the only possible way is the root locus must travel straight to the nearest pole. Okay, so sini. Boleh tukar color tak? Okay, so the root locus must start from here and go to the nearest pole. Okay, that's why dalam jawapan dia ada satu garisan start dari sini ke sini, okay? So that's the only possible, okay? You cannot draw it going up, okay? Because if you draw going up, then you must have a symmetry, another root locus that is symmetry with the one that you drawn, okay? So to ensure symmetry, the only possible way is the root locus is a straight line from this point from this pole to the nearest 0. Okay, so this is the first root locus. Okay, so you know just now that the root locus must have 4 branches. So this is one of the branch, okay? One of the branches. So you must draw 3 more branches of the root locus. Okay, so we look at these 2 poles here, these 3 more poles. So these 3 poles, the root locus must go to the infinity because you only have 3 infinity 0. Okay, because 0 here already used. Okay, so you cannot make the root locus from this pole go to the same 0. You cannot do that. Okay, meaning that 1 0 and 1 pole only berpasangan. Okay, so you cannot draw all of these poles going to the same 0. So dia kena pergi ke pasangan yang lain. So kita tengok dekat 2 ni dulu. So you know this is the asymptote. So the root locus cannot cross this asymptote. Okay, so the only possible way is that the root locus must start here from the poles, and then it will break away. Okay, break away from the real axis and going to infinity, because the only possible direction dia boleh pergi that the poles can go is to infinity. So infinity is somewhere outside of the lines. Okay, so dia kena break away. Okay, so dalam soalan tak suruh cari break away. Okay, tak apa, sebab nak cari break away dia impossible lah by hands. Okay, so you have to estimate, okay, where is the breakaway points. So the breakaway points cannot be here, cannot be more than sigma A, because if more than sigma A, meaning that root locus awak nanti akan cross asymptote tu. So the breakaway point must be less than sigma A, mesti sebelum asymptote ni. So roughly we assume breakaway points ini roughly secara kasar. So both of the poles will travel to the breakaway point, and then dia akan break away. So dia akan keluar and then cross the JW axis crossing. So this is one branch, and another branch must be symmetry. Okay, so symmetry. Annoying gila. Okay, abaikan garisan yang saya ingat. Okay, lukislah macam mana pun. Tapi dia akan cross JW axis crossing. Okay, so this is second branch. This is the third branch. So you have 1 branch, 2 branch, 3 branch. So we need 1 more branch, okay? Because you have 4 poles, meaning there are 4 branches. So root locus dari point ni mesti go to infinity. So it cannot travel back, okay? Dia tak boleh patah ke belakang. Kalau dia travel ke belakang, maksudnya dia akan sampai ke poles ni ataupun sampai ke 0 ni. Okay, maksudnya dia tak boleh ke belakang lah sebab 0 ni dah dimiliki oleh these poles. Okay, so the only way dia boleh travel is going to infinity, negative infinity. Dia tak boleh keluar. Kalau keluar dia tak symmetry. So this is your fourth branch. Okay, so this is your root locus scratch. Okay, so first branch here from poles to 0. 2 more branch from these 2 poles, break away and going to infinity. And the last branch start from this pole and going to negative infinity. Okay, boleh dapat idea tak macam mana root locus ni nak sketch? Kalau tak faham, tanya je, okay? Okay, kalau tengok dekat slide 4C yang jawapan dia tu, so dia ada 4 branches. Okay, so the first branch is here, and then the second and third branch, it will break from this point. Okay, bukan dekat garis dekat sini. Sini ialah the asymptote, the real axis asymptote, and then they break, and then the fourth branch is here, from this pole going to infinity. Kalau delete ni, so garisan biru ni ialah the blue lines here are the asymptote. Okay, okay, ni salah. Okay, any question? Kita move on to the next question if you have no question. Okay, so for second question, so given unity feedback system, so also unity feedback, first find the JW axis crossing and then K value for marginally stable system. Then determine the breaking point, determine the angle of departure, and sketch the root locus. Okay, so let's look at how to answer this. Okay, so the trans function is given as GS so GS equals KS plus 2 divided by S square minus 4S plus 13. Okay, so first rule, you need to find the poles, okay? Poles and zeros. So poles is at S square minus 4S plus 13 equals 0. So use calculator. Sekejap cek jawapan. So if you use calculator, S equals 2 plus minus 3J. And then zeros is at S equals minus 2. And since you have two poles, first is 2 plus 3J, second one is 2 minus 3J, and you only have 1 0 here, so you add one more 0 at infinity. Okay. So here indicates that there are two branches for the root locus. Okay. And then the question asks you to determine the JW axis crossing. So we can start by calculating the closed loop transfer function. So closed loop transfer function. So this is unity feedback, so you can straight away get the closed loop transfer function, okay? And then after that, you determine the denominator. Okay, expand and simplify. So you will get S square plus k minus 4s plus 2k plus 13. Okay, then you use Rauch-Hurwitz table. Start from S2, then followed by S1. So here 1, k minus 4, 2k plus 13, 0. And then here 2k plus 13, 0. So to determine JW axis crossing, to determine the value of k for marginally stable system, you use row S1. Okay, so use row S1. So k minus 4 equals 0. So you get k equals 4. Okay, so k equals 4 for marginally stable. And then you use this value of k, substitute in row S2, okay, to determine the JW axis crossing. So use S2, S squared plus 2k plus 13. So 2 times 4 plus 13 equals 0. So you get S equals plus minus 4.58 J. Okay, so this is the JW axis crossing. Okay, so you just note, okay, JW axis. Okay, so that's answer question A. Dalam slide betul tak? Betul. Okay, after that, question B asks you to determine the breaking point. So rule number 3, breaking point. So you need to use the formula sum of 1 over s minus poles equals sum of 1 over s minus 0. So there are one pole, so 1 over s plus 2. Okay, s plus 2 equals 1 over s minus 2 this. So you will get s minus 2 minus 3j Okay, simplify, you will get s square minus 4s plus 13 equals 2s square minus 8. And then further simplify, you will get s square plus 4s minus 21 equals 0. So you have 2s, s at minus 7 and 3. So the breaking point, there are 2 breaking points. One is at minus 7 and one is at 3. Okay, so minus 7 here. So basically you need to choose only one, okay, because of the nature of the root locus. But I think answer like this also okay, but just put label here, breaking point at s minus 7, okay. And then question C asks you to determine the angle of departure. So angle of departure and angle of arrival, rule number 7, is only for complex poles and zero, okay? Only for complex poles and zeros. So here you have complex poles, okay? Because you have 2 plus 3j. So 3j here is complex number. Here the 0 is not complex number, it's a real number, minus 2. So you only need to calculate the angle of departure for these two poles. So before you can calculate the angle of departure, you need to sketch them, okay? Sketch them roughly in a S-plane. Oh. Okay, so roughly, so plus 2 at 3j. So this is 3j minus 3j, 2. So the pulse is here. And the 0 is at minus 2. So somewhere here. Okay, so to calculate the angle of departure for this point, okay, to calculate this angle, first you need to draw lines that connects all the zeros and poles to the poles that you want to calculate the angle. So first line is here. This is 90 degree. And the second line is here. Okay, so theta p equals, so the formula is 180 plus theta z minus theta p. So 180 plus, so this is theta z, theta from 0. So here it's tangent minus 1, 3/4 minus this angle, 90 degree. So you will get 126 degree. You need to look at where the angle is measured, okay? So I got negative 233. So 233 is measured from here to here. So basically 233 is measured from here to here. So you need to take this angle, okay? So angle of departure is 126 degree. And this angle for this pole also the same, okay? So this angle also 126 degree. So this is 126. The bottom one also 126 because they are symmetry, okay? So this answers question C. Okay, now we sketch them in sketch the root locus. So the first step you need to do is to sketch the poles and zeros. Okay, so then okay, so the first pole is at 2 and plus 3j and minus 3j. So it's here, here, and then the 0 is here, minus 2. Okay, sketch the pole and 0, you get 1 mark. Okay, so don't forget. And then after that, plot the JW axis crossing, which is this one, 4.58. So it's somewhere here. Okay, and then put the breaking points. So breaking point is at minus 7. 3, 4, 5, 6, 7. So somewhere here. And plus 3. And then lastly, the angle of departure. So angle of departure. So same for the bottom one. Okay, and then you can sketch the root locus. Okay, so there are two branches. Okay, two branches and one pole and 1, 0. So one of the pole will go to the 0 and another pole will go to the infinity. And you need to ensure symmetry, and the root locus must somehow comes into or goes into the point here, -7, meaning that it breaks into the real axis. So the only possible root locus that you can sketch is it will start the same, meaning it will go up and cross the JW the point -7. After that, one of the pole will go to the 0, -2, and another pole will go to infinity. So we sketch them. So here it will start here and then cross the JW axis crossing. And then it will go, alah buruknya. And then it will go to the breaking points. So same for the bottom pole. Cross. And then go to the breaking point. And then one of the branch will go to the -2. Another branch will go to infinity. Okay, so this is the root locus. Okay, ni lukisan buruk tak ada pembaris. Korang lukislah dengan pembaris. Okay, you will see here that the breaking point equals 3. There is no root locus here because root locus must start from poles and goes to the left. So dia tak boleh ke belakang, okay? So dia tak cross lah point 3 ni. If you look at the slide, dia bentuk bulatan macam ni. Okay. Okay, any question so far? Ke dah pergi makan? Okay, so that's it for today's class. So for Friday class, we will discuss more example in the slide 4C. For example, this question, and also this one. And then, so you are given assignment 4. Oh, ni sebenarnya. Okay, so you are given assignment 4. So the rule locus is already given here, but you need to determine all the necessary rules, okay, like asymptote, imaginary axis, and so on. So if your question before determine all of this, so the best practice that I ask your previous senior, I ask them to determine all of this first. After determine, then you can sketch. Okay, sometimes when you sketch, you don't know where is the asymptote, where is the JW axis crossing, where is the breaking point, and so on. So try to answer the other question first, and then lastly baru sketch. Okay, sebab dah tahu semua ni, baru boleh nampak dia punya bentuk root locus tu sedang menghadam. Okay, so okay, try hadam lagi. Dan assignment 4, the deadline is Sunday, and also your take home quiz. Okay, take home quiz also Sunday. Oh, ni ada S+5 landscape. Oh, ni lain. Tak apa, buat lah. Okay, so that's it for today's class. If you have any question, boleh tanya sebelum saya bersurai. Okay, so that's it for today's class. Assalamualaikum and goodbye.
Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Bye.
Love you.
Love you, sir.
Love you too. Love you too.
Muah sikit.
Muah.
Ada ke ada?
Muah sikit.
Ni si siapa nama tulis?
Sini si cute mute
Akmal Juwati.
ni Yuni ni.
Ni. Thanks semua sikit.
Okay, sir, thank you.
Founder ni.
Sorry.
Bye.
Bye, sir.
Papa Raja.
Tak keluar. Nanti.
Kenapa buka video?